Hello, geometry students. This is lesson 4.4 for both parts A and B. And we're talking about proving triangles congruent by angle, side, angle, and angle, angle, side. We've already talked about proving them congruent with side, 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 or side, angle, side, right? With side, 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 we have all three sides are corresponding to all three sides of a different one. Over side, angle, side, we have two sides and the angle between them. That's why it's side, angle, side, side, angle, side. So today, we're going to be talking about angle, side, angle. So you have an angle, a side, and an angle. So two angles and the side between them corresponds to two angles and the side between them. Or angle, angle, side. So two angles and then a side. Two angles and then a side. When you are asked to give a congruent statement about a triangle, the order really matters. So if it says triangle XYZ is congruent to triangle ABC, this one statement means all of these six things. It means X is congruent to A, this X angle is congruent to A, Y is congruent to B, Z is congruent to C. And the segments XY is congruent to AB, YZ is congruent to BC, and XZ is congruent to AC. So make sure that as you're writing those congruent statements that you put them in the correct order. Alright, so on these, this is obviously a screenshot, so I can't really extend these, but you can extend these out, and you're trying to see if you can make these match this one over here, or if you could make a different triangle. If the only triangle you can make matches this one, then you would say the two triangles have to be congruent, and then you would pick from those four options of side, 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 angle, side, angle, or angle, angle, side. In this case, since we have an angle, a side, and an angle, a side, and an angle, we would pick angle, side, angle. For this one down here, we could, this side is fixed, so we could move this one longer or shorter, and we could also change that one's angle. So if we connected this one, if we went to that, it looks like these two are going to have to be congruent. And since I have a side, an angle, and a side, an angle, and a side, I would pick side, angle, side. Now for these next ones, we're trying to determine if these would be congruent or if they don't necessarily have to be congruent. So notice here I have an angle, a side, and an angle, right? The yellow corresponds to yellow, blue to blue, red to red. So that would be an angle, side, angle. So then this would be congruent. And my congruent statement, so since this says M and O, M is the side with nothing on it, so that would be corresponding to, this would be R. The N is the one that in blue, so that would be P. And then the O is in the yellow, so that would be Q. And then, again, how would we know this? This would be the angle, side, angle. For this next one, I have a side, an angle, and a side over here, but notice the order changes over here. So this side does correspond to this side, and that side to that one, and that angle to that one, but this is a side, angle, side, whereas this is a side, side, angle. So in this case, this would be not necessarily congruent because the order doesn't matter. Then down here on this one, I just realized that I had pre-wrote these out. So I don't need this one. This would go right there. For this one, this is a side, angle, side, and it corresponds to the side, angle, side. So this would be congruent. It starts off with A, B, C. So A is at the end of the blue line. So this would be F. This would be F. The B is the one at the end of the red, so that would be D. And then C is the yellow, so that would be E. Alright, this one says, use the given information to prove that these two triangles are congruent. So I've kind of pre-made marks. This is a right angle, this yellow one here is a right angle, and this one over here is a right angle. And I also know that this segment is the same as this segment. So I've kind of inserted these three into my proof. And now I need to draw a conclusion here. Because I know this angle and this angle are both right angles, I could say that angle RST is congruent to angle UVT, and the reason would be all right angles are congruent, right? That makes sense. If they're both right angles, or they both measure 90 degrees, that means they have to be equal to each other. So now I've said I have a side is the same as a side and an angle is the same as an angle. So I need one more piece of information, and I know that this angle, UTV, angle UTV, is congruent to this one, RTS, because those are vertical angles. So now I have this side here, and I also have this angle is congruent to that angle, and the two right angles, so that's going to be an angle, a side, and an angle, a side, and an angle. So then I would insert this into here, and then I would say angle, side, angle, congruence property. Here's another proof. It says use the given information to prove that these two triangles are the same. So again, I've highlighted this EF is the same as GF, and this line, this blue line, bisects this red angle. So I've went ahead and inserted those givens into there. Now when it means that it bisects an angle, it means that this red angle is cut into two congruent parts. So what I can do is I can say angle GFD is congruent to angle EFD. And that's the definition of angle bisector. That's what it means to cut an angle in half. So then what I just showed is that this angle is the same as this angle. Then also by the reflexive property, I know this line DF is going to be congruent to the line DF. And therefore, since we already used this point, we know this segment's the same as this one, this angle's the same as this one, and this side's the same as this one. So then I'll insert that into there, and that would be by side, angle, side. A couple more proofs. This one doesn't give us much information, actually. Just because it's this one, it says, given that QS, this line right here, is a perpendicular, that's what the upside down capital T means, perpendicular bisector of PR. So perpendicular means it meets at a right angle, bisector means that it cuts it in half. So let me go with the bisector part of this. So bisector means that PS would be the same thing as RS. So I'm just going to say that. PS is congruent to RS, and that's the definition of bisector. Now, let's go with the perpendicular part of that. I know angle QSP is a right angle, and there's a button that you can do is a right angle, and that would be by the definition of perpendicular. And likewise, I could say angle QSR is a right angle, again by the definition of perpendicular. And then because all right angles are the same, I can say angle QSR is congruent to angle QSP, because all right angles are congruent. So far what I've shown here is that this angle is the same as this one, this side's the same as this one. So I just need one more piece of information, and I think I can do that with this QS. I can say QS is congruent to QS, and that's the reflexive property. Now I have a side, an angle, and a side. So I can insert that final statement that I need, and that would be by the side, angle, side congruence property. And I know you guys are just having so much fun with these proofs, but this is going to be our last one. Sorry. If you want to watch them again, feel free to go back. But this one is going to see if we can pull in some information about perpendicular lines. That's what these two vertical, looks like a vertical equal sign. So this means that BC is congruent to AD, and then this says that CD is congruent to AB, and that's what these little arrows that I put on there are. Means that this one and this one are parallel to each other, and this one are parallel to each other. And I'm trying to prove that BC, this length, is the same as this length. That's what I'm trying to show. So let's see if I can do that. Now I will point out that up until this point, we've just been trying to show that two triangles are the same. And so I'm going to teach you one thing new, that once we show triangles are the same, then we can conclude this. So, sit on the edge of your seat as I get to that. But kind of the idea is that I want to first show that this triangle, ABC, is going to be the same as this one, which would be CDA. So that's kind of like my preliminary one that I'm going to do, and then I will get to proving this. So here we go. First of all, I remember that if two lines are parallel, right, that the alternate interior angles, this one and this one, would be congruent, right? Just to help jog our memory, if I have parallel lines and they're cut by a transversal, alternate interior angles would be congruent to each other. So let's see if I can name those. That would be angle BAC is congruent to angle DCA, and the reason would be is if parallel lines, then alternate interior angles congruent. Might say if lines parallel, but something like that. I should be able to find it. So I just showed with this is that this little angle right here is the same as this one. Now I can do something similar for the other lines, right? Because this one and this one, so if I have parallel lines and they're cut by a transversal, I know this one is the same as this one. So this one should be the same as this one. So I'm going to say angle BCA is congruent to angle DAC. And it's still that same thing. I think it's if lines parallel, then alternate interior angles are congruent. Thankfully for you, you have a drop-down menu. Okay. Now, I'm also going to conclude, or also going to remember that AC is a shared line for both of them. So I'm going to say AC is congruent to AC. That's the reflexive property. You guys probably have that one down by now. And now, because I said an angle, a side, and an angle corresponds to an angle, a side, and an angle of two different triangles, I can conclude that triangle, I'll say ABC, is congruent to, and I need to make sure I'm sticking the same order here, this would be triangle CDA. And I would know that by the angle side angle property. Now, because we know those two triangles are congruent to each other, we know all the corresponding parts. So this part, AB, corresponds to CD, right? AB corresponds to CD. So that means these lengths must be the same. I know AC must be the same length as AC, which we actually already showed. And the one that's actually important to us, this BC, is congruent to AD. So I can actually now insert this final statement here. And the reason is corresponding parts of congruent triangles are congruent. CPCTC is the reason for that. I think that one's at the very bottom of your list. So CPCTC stands for corresponding parts of congruent triangles are congruent. CPCTC. All right, like I said, if you need to watch one of these over again or watch it in slow motion, you can do that. Good luck, guys.